closing ceremony right now, and before doing that, I have a short service announcement to make. Somebody forgot their Alienware adapter, so if you're missing it, you know, we're gonna leave it here on the stage for you. Okay. So we're gonna go straight to the amazing parts of UIST. There's so many amazing parts of UIST, but one part of it is also that we get to honor some of our papers. And I wanted to say, you know, huge thanks to Dan Vogel, who was the awards chair. He handled all the paper selection process. He recruited an amazing best paper committee, and they did all the work. The program chairs were not involved in that. However, you might be wondering why I'm standing here alone. It's because some of the program chairs also write fantastic papers and therefore get an honorable mention award. So we ask everybody who sees their name on the slide right now to come up to the stage, and then we're gonna do the, we're gonna hand you your awards. So everybody, every author who sees their name, please come forward, come forward, come forward, come forward. Okay, so the first paper that we are, that received an honorable mention award from the Best Paper Committee is Can a Smartwatch Move Your Fingers? Compact and practical electrical muscle stimulation in a smartwatch. The authors are right here. Akifumi Takahashi, Yudai Tanaka, Archie Tamahane, Alan Shen, Shanyuan Teng, and Pedro Lopes. Congratulations.
All right, now I can take in as a presenter too of awards. Our next amazing paper, which also received an honorable mention, is Blendscape. I see you folks already there. You can join us on stage while I talk about Blendscape. This is Shweta Krajaman, Nels Newman, Bala Kumaravev, Nick Marquardt, and Andy Wilson from Microsoft Research. If you haven't seen, Blendscape is a system that will get you never bored with video conferencing again. It's a system that uses image generation techniques to allow sort of like the end users to customize what they see and what they do and how it feels in video conferencing. So let's really give them a big round of applause and take a photo with them.
Thank you.
Congratulations. Thank you. Congratulations.
Okay, so we have the next honorable mention award, which is Exploring the Effects of Sensory Conflicts on Cognitive Fatigue in VR Remappings. The authors are Chenren Luo, Gaojiang Cheng, Yiqian Wen, Pengxiang Wang, Yachuan Fang, Tong Han, and Fang Tian. So please come up to the stage and receive your awards. If you're still around. Okay, we're gonna ship it to them. They made a lot of fantastic contributions, including investigating the impact of sensory conflicts induced by VR remapping on cognitive fatigue, and they unveiled correlations. They tested a lot of different mappings, and all of the mappings that they tested did influence cognitive fatigue, and visual vestibular conflict had the most impact. So congratulations to the authors in absence, and they did a great work.
The fourth, but not of the least of our honorable mentions, is the paper for Wheeler. This is a paper by Tohad Islam, Noshat Sujib, Imran Kabir, Ashikur Rahman Amit, Mohammed Rahul Amin, and Syed Masum Billah. Please come on stage. If you have not seen this paper, this is a really cool and novel 3-wheeled mouse for input. And instead of like just one kind of like hierarchical movement you can do, you can kind of do 3-level hierarchical things. In their study with blind users, they actually found this reduces navigation time by like up to 40%. You should definitely check out the paper. Really cool. And feel free to come on over closer to Alex so we can take a photo. Congratulations. Let's clap once more. Congrats. Wonderful. All right. We are now transitioning to also 4 best papers awarded by Dan Vogel together with the Best Paper Award Committee. These are, again, the titles, and if you see your names in there, do the same spiel. Please line up here so we can really celebrate your paper and you know, give you your trophies as well. By the way, these trophies were designed with a lot of work and help by student volunteers, Chris Harrison, local arrangement chairs, and a lot of other people. So a round of applause to that as well. All right. The first of our 4, so if you can like arrange yourself, so the first one is here, is augmented physics, creating interactive embedded physics simulations from static textbook diagrams. This is work by Aditya Guruntu, Yi Wen, Nanji Zhang, Jarin Tundahil, Rubayat Habib Kazid, and Ryo Suzuki. This is work from University of Calgary, Texas A&M, Adobe Research, and Colorado Boulder. Come on, guys. Come on over. If you have not seen this talk or read the paper yet, I highly recommend. This is a computer vision LLM-powered authoring tool designed for creating embedded interactive physics simulations. Like, it just takes static book things, textbook diagrams, and makes them come to life. It draws from an elicitation study with physics instructors, which is, I find, really, really cool. And then they did even more studies to it. So let's celebrate all that with this award. Congratulations. Congratulations.
All right. The next Best Paper Award goes to Ear Hover, mid-air gesture recognition for hearables using sound leakage signals. So the authors are Shunta Suzuki, Takahashi Amisaka, Hiroki Watanabe, Bontaro Shizuki, and Yuta Sugira. Please come on stage. So this paper made really amazing contributions in enabling mid-air gesture input for hearables. It uses sound leakage to detect reflection caused by the hand movements during mid-air hand gestures. So they tested 27 different gestures, and they determined the 7 most suitable for ear hover across a really wide range of design spaces.
All right, we're trucking along really well. You ready for the next one? All right, this is What's the Game Then? Opportunities and challenges for runtime behavior generation. This is Nicholas Jennings, Hang Wang, Isabel Lee, James Smith, and Bjorn Hartman from the University of Berkeley. Come on onto stage, and let's clap for them as they do that. This is a novel LLM-based runtime behavior generation system. If you do Unity, you don't need to do it anymore. Essentially what they made is a really beautiful system that when triggered by player action, it generates kind of relevant behavior, which is compiled and just happens in the game. It doesn't need any developer intervention. It's just inside of the game engine. Really beautiful. Let's clap again for their work. These countdowns are interesting. Congratulations.
All right, and the last but not least Best Paper Award goes to WorldScribe, towards context-aware live visual descriptions. The authors are Rui-Che Chang, Yushuan Liu, and Anhong Gu. Please come on stage. So WorldScribe is a system that generates automated live, real-world visual descriptions that are customizable and adaptive to users' context. For example, for accessibility, it is adaptive, but not only to visuals, but also to users' intent and sounds. Congratulations.
All right, I get to do transition to these beautiful people here on stage. This is going to be Jack Foreman and Perna Ravi. They are our diversity chairs presenting one more Best Paper award, which is incredible.
Hello, everyone. Unfortunately, Perna cannot be here today. She had to go home, but I'm Jack Foreman, and this year my co-chair Perna Ravi and I are really excited to introduce a Belonging and Inclusion Best Paper Award. We are humans designing technologies for other humans, and this award provides an explicit opportunity to highlight and incite discussion on the best practices that can be both subtle and also explicit, that expand our humanely technological perspectives that define our field. We decided not to publicize this award beforehand because we wanted to know that there were enough papers that were eligible to justify the award, and there were. The discussed papers were selected from the short list already being considered for Best Paper, and 4 papers were considered, discussed at length with both the diversity chairs as well as the accessibility chairs. The selection rationale was forwarded to the general chairs and finalized. And we just want to note, before I get into why this paper was awarded, that this award and the criteria for it are a work in progress. And moving forward, we're going to be writing up a blog post about about how the selection process occurred, and we're actively seeking feedback from the community so that in the future, this criteria can be refined and formed democratically. So if you have thoughts, reach out to diversity2024@UIST.org so we can include your voices in the discussion. We want to thank Mayank, Linning, Dan Vogel, and Chris Harrison for their supports in our spearheading of this effort. And with all of that said, and also, of course, to Hua Shupeng and Yao Deng, the accessibility chairs who helped us select this paper, the award this year goes to Cooker, affordance augmentations in wearable AR to support kitchen tool interactions for people with low vision. So if you see your name on the screen, please come forward and receive your award. I see some authors coming up. So the authors are Jay Lee, Andrew Tahati, Jiho Kim, Jongyu Yu, Minji Park, Jiawen Zhang, John Froelich, Yapeng Tian, and Yuhong Zhao. And this paper was selected for multiple reasons. The paper generally is a head-mounted AR system to support safe and efficient interaction with kitchen tools for people with low vision. And it was selected because it provided a nuanced discussion on the difference between designing for people with low vision and the difference between designing for people who are fully blind. Second, the authors went to honorable lengths to recruit a diverse set of users for their user study and from multiple cities. And finally, the paper then directly included those users into a brainstorming and co-creation process. Throughout the entire paper, there was this unmistakable feeling of care and passion for the communities that they were designing for. It's a really wonderful paper. I encourage you to read it. And so let's give a big round of applause for our first ever recipients of the Belonging and Inclusion Best Paper. Great, thank you all so much, and thank you again. And please do reach out. We want to feedback, and we want to see how this develops.
All right, so it's time for the Best Demo Awards. Me and Eric had the pleasure of hosting this demo session. Before anything and announcing the awards, I just want to make sure that, like, you know, we give a round of applause for all these amazing demos. You guys, most of you did a fantastic job. Thank you so much. This was wonderful. And before we go to the actual awards, we also want to have a special round of applause for the demo jury. They had a very, very tough job. So Amy Powell, Andy Wilson, Anhong Go, and Ken Pfeiffer. They had a very tough job because there was so much good content and they had to somehow select the best demo award out of this. So without further ado, let's go on with the honorable mentions. First, the jury award honorable mentions. So as the spiel is, if you see your name on this slide, first of all, come over to the front, and we are going to announce your demos one by one. So please come to the front. Give a round of applause for these honorable mentions. And line up over here. All right. So for the first honorable mention, we have Thermal in Motion, which is presented by Haokun Wang, Yatar Singhal, Hyungya Gil, and Ji Ryong Kim. Please come to the stage. Congratulations. Congratulations. All right, give them one more round of applause. And then we move on with the demo demonstrating haptic source effector by Yudai Tanaka, Hunter Matthews, Jacob Serafati, and Pedro Lopez. Congratulations. And special mention, high school student who did a fantastic job in this demo. Excellent. All right, we move on with the next demo, Stegotype, which was presented by Mark Richardson, Fadi Botros, Yang Shi, Bradford Snow, Ping Hao Go, Ling Huan Zhang, Yingmin Dong, Keith Vertanen, Shou Gao Ma, and Robert Wang. One of them made it over here. Congratulations. All right, and then for the last honorable mention demo, we have Pointer Vol, which was presented by Unai Javier Fernandez, Elodie Bouzbib. Sorry. Ayosun Sarashta Ascona, Ingio Escuria, Manuel Lopez Amo, Ivan Fernandez, and Asier Masro. Big round of applause. All right, and then for the actual Best Demo Award. So we have one juried Best Demo Award. This was an amazing project. I'm sure you all saw it when you came into the demo session. The winner of the Best Demo Award this year is Artist-Centric CNC Tool Design by Ilan Moyer, Sam Burgo, Devon Frost, and Jennifer Jacobs. If you're around, please come to the front and pick up your award. No. Oh, we take a picture.
This is their trophy that they will receive.
The trophy is very cool. It spins inside out, but yeah, we will send it to them. There will be more of those coming. Excellent. All right, so next to the jury award, we also have People's Choice Award, which you all voted for. Thank you so much for participating in the voting. I know it was a bit of a challenge to log into your ACM account and remember your credentials, but might be a good thing to do in general. So for the People's Choice, we have 2 honorable mentions. If you see your name on the slide, please do come to the front. Lots of names on the slides. I'm looking forward. So one round of applause to the honorable mention winners of the People's Choice Demo Award. Okay, we found 2 people. Okay, so the first honorable mention award is the speed modulated ironing, which was presented by Mehmet Ozdemir, Marwa Alalawi, Mustafa Doan, Jose Francisco Martinez Castro, Stephanie Muller, and Zhenya Dubrovsky. Please come pick up your award. Congratulations. Thank you. And then for the last honorable mention, we have torque capsules, which was presented by Vila Junki Yang, Yifan Zhu, Jingle Huan, Raouf Abu Jaber, and Ken Nakakaki. Please come pick up your award. Congratulations. All right, another round of applause. And now the moment of truth. The People's Choice Best Demo Award goes this year to Ego Touch. It was just presented by Vimal, Morlin, and Chris Harrison. And come straight up the stage. Congratulations.
Thank you.
Excellent job. Great work. Congrats. Yeah, there's trophies. All right. Well, that's it for the demos. Thank you so much. And we move on with the best posters.
Great. We had a very exciting posters program this year. First of all, we would like to thank the subcommittee members and the jury that helped Koya and I decide which posters to include and also which posters should receive the jury award.
So first of all, I'm happy to announce the jury's award. So here are the titles for the jury's award. So if you see your name, please come to the stage. So the best poster award is given to Flexible, a tool for making 3D printable sensors and actuators, written by Xianling Li, Yujie Shang, Huachao Mao, and Liang He. Please come to the stage. Oh, by the way, award chair made us such a beautiful trophy. Congratulations. So, all right, the first honorable mention award is given to code shaping, iterative code editing with freeform sketching by Liang Yan, Jian Zhao, Daniel Vogel. Please come to the stage. Oh, you're only one. Thank you so much. And the second honorable mention award is given to ValueSphere, a portable widget for quick and easy shading in digital drawing, written by Hailim Huan, Seonjun Lee, and Seohyun Bae. Please come to the stage. Thank you so much.
Right, we're now going to move on to People's Choice Awards. If you see your name, please come forward and line up over here. I don't see a lot of movement. Are people here? These are the votes that were done on the program portal as of 11 a.m. this morning, so in case they change. All right, so the best poster People's Choice Award goes to Lost Start, an interactive stereoscopic picture book installation for children's bedtime rituals by Jiai Lu, Xingxing Qiu, and Jihan Gao. Congrats. First honorable mention, collision prevention and diminished reality through the use of peripheral vision by Min-Young Kim, Kun Woo Sung, Yuhan Lim, Sang-Hoo Young. Please come to the stage. Thanks. Our last honorable mention is Microcode, live portable programming for children via robotics. Lorraine Underwood, Thomas Ball, Steve Hudges, Eliza Rubegni, Pelly de Halix, Joe Finney. Sorry if I mispronounced your name. Congrats. All right. Now we're going to hand it off to for the Best Student Innovation Awards. Congratulations. Sorry.
Thank you, guys. All right, so the Best Student Innovation Contest, first of all, we want to shout out to our sponsor, Seed Studio. With their generous support, we can create this Gen M kit, which has like over 80 modules where you can use them for sensing, actuation stuff. So they work very hard to ship out all the modules around the world. And we have 8 teams selected this year. They present very well and polish the demo at the demo night. And you can see here we have a range of different applications here, from robotics to haptics, wearables, and some laser cut pieces here. All right, so we also want to shout out to the jury. We invited John Varlick from UW, Jian Kim from Texas AMU, and Koya Narumi from K University. And they really work very hard, and they have very active discussion that night. And let's give a round of applause to them.
All right, so this year we have 3 awards. Most Creative Award, Most Creative Project Award, and Most Useful Project Award, and then the People's Choice Award, of course, chosen by you folks. And I'm going to click the button here, and then the names will show up. If you see your name, please come here onto the stage. So Most Creative Award for this year's UIST Student Innovation Contest goes to MC GPT, leveraging large language models to enhance emotional empathy and user engagement in embodied conversational agents. So the authors are Ming TC, Mingyu Su, and Sun Chang Li. Congratulations, folks. Good job. Thanks. All right, so next we're going to have Most Useful Project Award. If you see your name, please come join us on the stage. So this year's Most Useful Award goes to Meta Controllers, sheet material-based flexible game controlling system. The authors are Chen Yisen, Yiming Zhao, and Rossio Sojitra. Good job, folks. All right, People's Choice Award. Again, if you see your name, come join us. Vibro Hands, in-hand superpower, enabling sparring, precognition, and telekinesis. So the authors are Jiwon Kim, Ho Hong Jun, and Ilan O'Kelly. we don't want to take photos, but just they've done that. All right, so next let's welcome the social media challengers.
All right, hi everyone. So back in the opening remark, we announced about the social media challenge. And we're so excited to see so much engagement in our social media challenge, whether you're like first timer at UIST and trying to pair up with someone you know or don't know about the conference. We have to see so much human-human interactions here. We see a lot of people trying out cool demos and post about it, and also ask about authors about their fun fact about their UIST work. And there are a lot more going on we see through the social media challenges, such as promoting their work, trying out demos, doing swag hunt, and we're so excited to so much engagement in this social media challenge. And here we're gonna announce the winner of the raffle.
Okay, so first up we have Shim. If you're here, please let's give her a big round of applause. Next up, we have Lorraine. If you're here, please come up to the stage. And then Philip. Let's give them a big round of applause. We have some fun goodies for you guys, so please meet us on the stage if you're here. If not, we can meet you later. Okay, I think we have one person. Okay. So let's give them a big round of applause.
Do you want a photo?
Yeah.
That's okay.
All right, so we'll hand it over to Bjorn Hartman.
All right, on to the Lasting Impact Award. The UIST Lasting Impact Award was established in 2003 to recognize UIST papers that have had a long-lasting influence on our field. Eligible papers for the award must have been published at least 10 years prior to today's date. This year, the Lasting Impact Committee was chaired by Patrick Bowdish and also included Mary Ringel Morris, Takeo Igarashi, and myself. Now, for the second year, we solicited nominations for this award from the community and considered those nominations alongside strong candidates collected over the years from past committees, as well as newly eligible papers. On behalf of the committee, I'm happy to announce that the UIST 2024 Lasting Impact Award goes to Gestures Without Libraries, Toolkits, or Training. A dollar recognizer for user interface prototypes by Jake Wobrock, Andy Wilson, and Yang Li from UIST 2007. Don't come up yet. First, got to embarrass you with some nice words about the paper. So this paper introduced a novel approach to stroke gesture recognition. The main contribution of the paper was that it took something that was generally considered to be hard at the time and made it easy and accessible. Up to that point in HCI history, it was generally assumed that writing a gesture recognizer was very hard and could only be accomplished by a small group of experts. The paper then refuted that assumption by showing that gesture generation recognition for the types of gestures that we care about in interactive systems for stroke inputs can in fact be accomplished with just a few lines of code. Namely, the algorithm in a nutshell is this. 1, you read an input stroke. 2, you place a fixed number of equidistant control points along the stroke. 3, you rotate and scale the stroke to a reference square. 4, you compute the path distance between the stroke and each of your training samples while fine-tuning the angle. And finally, you return the category of the training sample with the shortest distance. Done. The HCI audience found this straightforward to understand, to re-implement, and to use. And as a result, the approach has been re-implemented and used by a wide range of users in research, in teaching, in industry, and the broader community. That has given the work its impact. When building interactive systems, complexity often comes for free, but you really have to work hard to achieve simplicity. The dollar recognizer is a shining example that when an elegant idea is distilled to its essential core and communicated lucidly and clearly, tremendous impact can follow. In research, the paper gave rise to a host of follow-on projects that extended the capabilities, leading to a whole dollar family of technologies. In teaching, the dollar recognizer found use as both a component in student projects as well as subject of assignments in HCI courses. And in industry, the recognizer has been used in games, in interactive installations, and inspired gesture recognition in the Android framework. This paper also received several nominations by researchers in the UIST community over the years. I just want to highlight two quotes from those nominators. First said, the dollar gesture recognizer is undeniably one of the most, if not the most widely diffused UIST contribution of all time. And it epitomizes a philosophy of simplicity and replicability in technical solutions, an important characteristic that influenced others as well. So please join me in congratulating the authors on the UIST 2024 Lasting Impact Award. Please now come on up on the stage. All right, I'll now turn the mic over to Jake Wobrock to deliver the Lasting Impact Award talk.
Thank you very much. Those were really kind words. I'm very flattered. And I want to note that was Andy Wilson's third trip to the stage this evening. Andy, you could have just pitched a tent up here. Just moved in. All right, let's see. Can you help me see them? That's not my slide. Okay, so I've been to UIST many times, and I know at this point in the conference everyone's tired and wants to go eat pizza and go home. So I will try not to keep you too long. It's a real privilege for me to be able to deliver a few remarks that I hope will be thoughtful for our community, a little bit of a retrospective, a little bit of a looking back. I don't know how much sense I'm going to make entirely because I did actually have to fly in on a red eye, and I slept 0 last night. You know, when I was a grad student, I did pull a few all-nighters for UIST. I didn't expect as a 48-year-old full professor I'd be pulling an all-nighter for UIST, but here I am, having done that on an airplane. Oops, what just happened? Sneak previews, okay. This is not my laptop. So I wanted to call this talk Making Possible Things Easy. And that term comes from a phrase that Scott Hudson, that is Scott Hudson, a few years ago. Scott Hudson, so this is really special for me as well because I got my PhD at Carnegie Mellon, and Scott was a big part of my time there. Brad Myers was my advisor, and I learned a lot from both of them. But Scott Hudson said to me at one point something that stuck with me. He said, UIST is about making impossible things possible, but it's also about making possible things easy, and both of those should be in service of people. And I think especially for the younger up-and-coming students and people kind of new to UIST, the top line we see very clearly, right? We see these amazing demos that make something that very much seemed impossible suddenly come to life, right? It's suddenly possible. And it's like almost, you know, it's just a hair's width shy of magic. And so I think we're really familiar with the top one, but UIST actually has a long history of the second one too, about making possible things easy or easier. Things that you could do already, but they're just too hard, right? They're just not accessible enough. And so we'll talk about that. But if you look at the last 6 Lasting Impact Award winners, you know, there's a mixture here as well. The top line are a lot of making impossible things possible. And aspects of that are in all of these, but the bottom line is actually making some things that were possible but just really hard much easier. For example, Morris and Horvitz's search together. You could do a kind of collaborative search, but it was cumbersome and difficult and definitely not streamlined. That's just one example. And so UIST has a long history of both of these things, and we are firmly in the camp of making something that was possible much, much easier. So our question was, how can we make 2D gesture recognition easy? This was back in 2007. There might be some people in the room who are, well, probably born, but not very old. It probably seems like a really long time ago. It's making me feel old. And so, you know, it was the year the iPhone 1 came out in 2007, to give you a calibration point. Stroke gestures were around, but not that common. Touch screens were not everywhere yet. They were in research, but not in products and stuff. So that's just kind of the context at the time. In 2003, actually, I was Andy Wilson's intern at Microsoft Research, and I got to be the first intern to ever work on the Play Table, which became what Microsoft released as the Microsoft Surface, which was not what later became the Microsoft Surface, which was more of like a laptop form factor. They originally released this thing as the Microsoft Surface. It's a vision-based system looking up from the bottom. And Andy Wilson was one of the masterminds behind the original version of this. And my job as an intern in 2003, I was only my second year as a PhD student, was let's add some gesture recognition to this so we can do things like make strokes and swipes and circle things and draw symbols and question marks and, you know, draw a box around something, you know, those kinds of things. Things that now we frankly take pretty well for granted, I think. And so as I began to look into this, which I'd not implemented before, the main thing that stood out in HCI was actually from SIGGRAPH, and it was the Dean-Rubin recognizer, which many of you will have heard of. And it's a statistical classifier. And it's a feature-based classifier. There were 14 features that Rubin defined. You can see them listed here. And you had to know things like Mahalanobis distances and matrix inversions and discriminants and other things that I kind of knew, but not really. And as I was getting into it, it just seemed like it really shouldn't be quite this hard. And the paper didn't really tell me enough to actually build it. And so I had to work harder at this than I thought I should have to. And so I wanted something that seemed a little more straightforward. There's also dynamic programming approaches that have been around a long time, especially with handwriting recognition. You'll see me mention Tappert here in a few moments again, but Tappert had a paper on an elastic matching technique. That also seemed complicated. Gosh, I keep jumping ahead here. I have to not touch the touchpad. Okay. So what we ended up doing, I wanted to work on the interaction design. And so Andy said, you know, just do linear time warping, which is the thing on the left. Just stretch them out in time, make the template and the candidate gesture align in time, it'll be good enough. So we did that. It didn't work all that well. And so we could kind of work with the interaction design, but not well enough. So this bothered me for a while, and after the internship, I only got satisfactory on my MSR internship. I didn't get like extra good or excellent or anything. Andy gave me a satisfactory, and I thought that wasn't very satisfactory, so that bothered me. And so It was about 2 years or 3 years later, I was talking to Per-Ola Christensen and Shumen Zai, who had released their second shark paper, which was at UIST 2004, which won the Lasting Impact Award at UIST 2014. And they had used something they called proportional shape matching, which was an extension or a build on Tappert's elastic matching, but with zero look ahead, essentially less elastic than Tappert's approach. It was a simpler version of that. And I thought, well, this sounds like part of what we need. They're working in a constrained space on a keyboard, so they have a certain kind of rotational frame that they're in. But that part of the proportional shape matching sounds like something we could build on. And so Per-Ola and I got to talking, and he talked to me about, don't space things out in time, space them out in space, which was ending up to be the first step in the $1 recognizer. Then we had to define a notion of orientation, which we took to be the centroid of the gesture to its first point, which is only a rough approximation of a good alignment, but it was a beginning. And then some basic stuff like scale and translation invariance, and then compare to templates. So this is just a nearest neighbor template matcher, right? There's no statistical feature extraction, anything fancy, which is part of the point. So the rotation invariance step was the one that just took a little more doing. And the upshot here was that if gestures are actually the same, not identical, but of the same class, there's not local minima in the optimal alignment for the search space over the rotation search space. But if they are mismatching gestures, there's usually local minima. That's actually a good thing, because then we don't care if it gets stuck in a local minima, because the score will be higher for gestures that shouldn't match. And then we ended up with the question of how do we find the best alignment, and we used something called golden section search, which is based on the golden ratio, and it was a much faster approach than hill climbing or just brute force. So we went with that, and it worked really well, actually. And then I'll just point out that Yang Li, who was on this paper, of course, and was just on stage, a year later published an improvement on this, which found a closed form version without the iterative approach to find the best angle. And he called that protractor, which became a cousin in the dollar family eventually. And we ended up showing that we were 7.3 times more accurate than the Rubine recognizer, and we ran 80 times faster than dynamic programming, dynamic time warping. So we had nice results there. And a big step we took, which actually at the time was, I think, not done, I think it was unprecedented as far as I know, was we actually put the entirety of the algorithm in the paper. This was back when you only had 10 pages, including references. You could not go one character over or you were desk rejected. So this was a big choice to make if we take up that much real estate on our last page. And this is pretty low-level pseudocode, actually. It's nearly code. Just in more symbols. And so people could write this recognizer straight off the back of the paper, and that's in fact what happened. Felt like a risk at the time. Now it turns out to have been a good choice. And we put up an interactive JavaScript version and stuff, and then people began building it and sending me versions in Python and C# and other languages that we hadn't built it in. And suddenly, over the next couple years, we had the beginnings of what became a dollar family. So we approached multi-strokes with $, and we added protractor through Yang Li's work, and then $, protractor, and it's like they were mating and having offspring. Radu Daniel Vatvu, if you know him, he was working on point cloud matching with $, but also adopting this very simplistic, simplified approach. And then other people started implementing this stuff, and the naming scheme got a little out of hand. So there's $3, Protractor 3D, Quick Bucks, 1 cent, €1, that's a filter, 1 franc penny pincher, 3 cents, and then a few things that got a little bit like microvolt was the last one, which, but they all adopted this similar approach, and they all put the code in the paper, or nearly all of them did. So there really is a whole family of these, and they all kind of built on each other and improved things that the others before them lacked. This is something I think is actually, unfortunately, somewhat rare at UIST, is that we don't directly build on each other's work that often, and for good reason. If we're doing something really novel, sometimes there's not a direct thing to build right on. But this was a case where things were, from Tappert to Shark to the dollar recognizer, to the other dollars. You know, it was all kind of building on prior work, and that just feels sort of like how science is supposed to progress. Now, I know this is kind of more invention than science, but I think it's a bit of both, and they're working together here. The thing that makes me most excited, actually, is not actually what we did per se, but what other people did with what we did, because that's, after all, the goal. Within 1 year, there was a game studio. I'd never talked to them. They didn't reach out to me. That was part of the point, right? They can just do this on their own. POW Studios built Mr. Spiff's Revenge, which won $10,000 in the Dr. Dobbs Game Challenge for Best Windows Game in 2008. I didn't even know that was a thing, but it's worth 10 grand apparently. The judges were quoted in the review of the game saying, we particularly like the gestures that were used to control the game. So here's a little clip. I'm scared of this laptop, it's not mine. How do I play? Oh, just go next. You can see that's a heart, circles, and shield. You know, simple stuff, but it's an integral part of the gameplay. Fireballs, and then there's a really cool one. They like pow. Big things come in, kill everybody. So that's exciting. And you know, they never contacted us. We don't have any contact with them, but we just kind of ran across it, and that was exciting to see. That was within 1 year of publishing the paper. So putting that code in the back of the paper, I think, really helped. This is a project called Eden. By Ken, Miller, Bollensdorf, DeRose, Hartman, and Agrawala. Some of them are in the audience right now. Just a simple
Drawing
quick clip
an
where
L
you can
in
see
the
they're
stroke
using the
pad
dollar
executes
recognizer.
command to
In
open
this
a
case,
load model
recognizing
panel.
the gesture L shape.
From this panel, he selects the models he plans to use.
Here's a paper called Air Plus Touch by Chen, Schwartz, Harrison, Mainkoff, and Hudson. Also some people in the audience right now. And you can see there's gestures they make in midair that are then recognized.
This system allows us to augment touch by looking at the finger's movement directly before, between, and after touches.
So those are all dollar recognized gestures there. Let's see. Here is project on expanding the expressivity of smartwatches by Zhao, Laput, and Harrison. The usual suspects are still here. Let's see if I can get it to play.
Gesturally. For example, moving the watch in a circular motion, or writing a character, such as a V. This could be used for quick actions, such as activating silent mode or taking a photo.
I love that their clip
Finally,
doesn't
we ported
show
a
any
first-person shooter game
misrecognitions.
to use
It's lovely.
gesturally.
It's wonderful. Here's a paper by Zhang and Vogel. This actually was interesting because they used the dollar recognizer to do pose recognition, not path recognition. But they were able
We
to
developed a
adapt it for that
computer vision
purpose.
algorithm to identify
It's called
fingers and
finger-aware
hands when
shortcuts.
pressing keyboard keys. The hands are captured by a built-in laptop camera and a reflector. The system tracks the location of the keyboard to rectify it. Hands and fingers are tracked using contour analysis, heuristic rules, and the $1 recognizer.
This is a little
We
quiet,
use the
but it
system.
did say the
We
$1
developed a
recognizer
computer.
there. I promise, it's in there. This is not an academic project, but it's called Inkbase. It's part of a kind of interactive sketching application. This is just an animated GIF they have on their website, but it's showing the dollar recognizer at work recognizing a triangle. And then probably my favorite example is from a fairly well-known digital artist named Zach Lieberman and his collaborator, I'm not sure his first name, Nick, maybe Felsen. And it's called Landlines. I really encourage you to try it out. On a laptop, it's even better than this video, which is just on a mobile device. I'll first show it, and then we'll describe what's happening. can see they're basically traveling the world. They're exploring the world by making a gesture that then matches some kind of geographic feature somewhere in the world. They partnered with Google Maps to do this. And the one on Chrome on a laptop or desktop is really lovely because it's very high res and you can make strokes. So if you go to lines.chromeexperiments.com, you can try it for yourself. But that's also using the dollar recognizer. So people found it and found it useful and made much cooler things than the dollar recognizer, after all, which is really exciting for us. So just a few takeaways and I guess points of reflection. So definitely UIST is the place for novel, inventions, right? The first time something's been done. That should be here. We should never give up our coin of the realm. That's super awesome. But also it is a place that has a long history of contributions that make known things much easier to do. An example from the early days of UIST is all the work on UI toolkits, right? And ways to make interfaces just much, much easier and more efficient to build. Scott Hudson, Brad Myers, others have done lots of work in that space early on. For maximum impact, I think we do need to continue to prioritize both of these things, not just one or the other. And this means, I think, for example, trying to make your contributions easy to take up and use by others. I know that's hard to do with certain things. They don't all amount to a pseudocode algorithm on the last page of your paper. But you can still kind of keep this in mind and see to what extent that's possible. Enable others to replicate and maybe test your inventions, especially if they want to compare against them. Also takes a bit more effort, but if you think about it from the beginning of the project, I do think it's easier than trying to add it on at the end, which is tougher. Andy was talking about how, a lot of contributions are kind of black boxes to the outside, but what we tried to do was really an example of a white box, right? Really shining the light on the internals and how things work, making it really easy to do. One of the nice compliments that we've gotten is how many people are teaching this in their classes. Rob Jacob actually just told me that today, that he's still teaching it because intro-level students can actually understand what's going on, and it gives them access to gesture recognition in a way that doesn't intimidate them because they have to invert a matrix or something. And then, think beyond your UIST publication. Like what's your invention life beyond the publication look like? I do realize some of these things are at odds with commercial incentives, so, we do our best. And that's it. Thank you. Appreciate your time. I guess I was told that we can maybe have a little Q&A. I don't know how much time we have, but and I would really implore my co-authors to come up here for these. You're not getting off the hook. Come on. Andy Wilson, fourth time to the stage, please. Come on, Young. We'll field these together. The hard ones you guys get.
Okay, so this might be easy, but still, we can get started with that. So a lot of times when you submit a paper which is easy, a lot of times you might get reviews which are, say that, well, it is easy, so do something else. So did you get this paper rejected ever? Tell us the rejection stories.
That's a good question. I will tell you that it was accepted the first submission, but it was the lowest rated paper that got in. And I only know that. That's not no one violated a confidence. I only know that because I was on the program committee. And so I was out of the room, of course, but when I came back in the room and I saw it actually got accepted, it was way down the list. There were like 5 or 6 papers above it that got rejected, and somehow someone thought that might be worth accepting. So very nearly, yeah. And you're right, you get that, right? It's not hard enough, it's not fancy enough. I think that's a point of reflection for us, right? There's like Bjorn said at the opening remarks, there's good ways to be simple and there's hard ways to be simple, right? Being simple shouldn't be taken for granted as a trivial thing to do, right? Simple's good and not always easy to achieve. Yeah.
Hello, Alex Sova of Google. Also confessed to one of the implementations, maybe later.
That's right, you sent me one, yeah.
Yeah, I really loved like the whole project. I was wondering if you can comment, do you see any like nuggets in sort of the current state of AI hype where you're desperately waiting for some cool tool to accelerate things?
Yeah, he's with DeepMind.
Well, I think in terms of a task, right? So we have a much better technology to actually do this now. But I think what people should take away from this work is that, as Shakes actually said, right? It's a white box approach, and people really know what's going on under the hood, right? So it's not like something like these large models. We don't really know actually what happens. So another thing is about the benchmark. I think that's what's really valuable for our field, to directly build on top of each other's work, right? So you can really check the progress. I would just talk about this.
Good answer.
Thank you.
Hi, thank you for the great talk. I'm Vivian from CMU. You know, as much as we include our code or open source or repositories in our current work, I feel like sometimes with the amount of research that's coming out, it can be a little difficult to publicize that work and like hope that people read and like use your work. I'm curious for this paper if there's any ways outside of just including the code that you were able to publicize and do outreach for your work, and if you have any tips for like in the current climate of research.
I mean, it's the webpage. Jake had the foresight to put together a nice website where he collected all the implementations as people sent them to him. And you know, I think one of the things that was important was we decided to not patent or do any protection. We made it in the public domain straight off, and that was something that we thought about a little bit, and I think that was key. If you think back to that time frame, there was all sorts of thinking about codecs and how they were being protected by the companies, and people were not using some of those things, and I got to witness some of that at the company at Microsoft. And so we decided, you know what, and I did this probably without permission, to just not worry about it. And I think that was an important fact, right? Important decision. But really, I'll say, really, the website was the key. Those two things together.
All I was going to say is, in that very wise choice, you made up for my satisfactory rating.
Didn't realize you're harboring like this angst. Good job, Jake. You've done good.
Thank you. Hi, Bingjian Huang from the University of Toronto. Thank you for the great talk. I think my question is surrounding, as we're having more and more hardware research in the WIST community, apparently open sourcing hardware is pretty hard. And also for people who want to use the open source hardware is also hard because they need all the, the machines to manufacturing the hardware. I wonder if you have any thoughts or any future vision on this side. Thank you.
Thoughts about hardware? And open sourcing hardware?
I mean, I can say one thing short. I'll just say one thing really short, but then you still have to do it. Which is, I don't know how many projects bother to make a project dedicated website, bother to publish their circuit boards or their specs that could at least sometimes could be reprinted by somebody. Maybe, I think we try not to put stuff in WIST papers that take up space that feel, like Mayank said, kind of the easy parts or the familiar parts. We try to make it all kind of novel and shiny. And we've created incentives for each other to do that. But the extent to which we can get the banal stuff that makes it possible out there, like Ruben could have written his paper in a way that was a lot easier to actually build his thing. And a lot smarter people than I have built it, but well, actually Young built it for us, so that's proof of what I just said. But a lot of us don't, there's a similar movement to try to do plain language summaries of research that are shortened versions that are digestible by the general public, especially in the accessibility community. We're trying to do more of that. That's another example of trying to make our stuff, you know, I don't want to break it to everybody, but like no one reads our papers except each other for the most part, right? For the most part. I mean, there are some exceptions, but for the most part, no one's out reading WIST papers. No product groups read WIST papers. It's very rare. So we have to, you know, I think we're good at making videos that help get those things out, but there's more that we can do there. But it takes effort, and then often we get the paper, we check the box, and we move on. And I think we just want to question that a little bit.
You know, this really doesn't have anything to do with hardware, but I do think it's really interesting to watch how the AI community has sort of progressed into this mode of having a project page that's, you know, maybe hosted on GitHub.io, right? And then you have the link to the paper, to the source code, to the demo. And like, it's hard to imagine, but back in when we were doing this work, people weren't really doing that. Is there an analog to that for hardware? I don't know. Maybe somebody can answer that question. I feel like people have tried, but it hasn't maybe stuck.
That's already a pretty good answer. Yeah, thanks.
Thank you.
As we know, at this point, it takes a few seconds for the slides to come. So 1, 2, 3, 4, 5, 6, 7. 7 seconds. That's a lucky number, right? All right. So I hope everyone had fun over the last 3.5 or 4 days. Yeah, Jake was right. This laptop is running on something. So all right. So 3 days of non-stop content. Right, we had a lot of fun. So everyone who had fun, you can quickly raise your hands or clap, either of those two things. Okay. So it's been an incredible program of talks, posters, demos, everything. And I think we all have had fun. And the banquet yesterday, I think, was amazing. Right? Like, we had a great speaker. The food was, I've heard, was very good for the most part, I guess. I would have liked some chocolate in the dessert. I don't know how many of you agree with me. But many thanks to the organizing committee. Another page of organizing committee. So let's thank everyone on the organizing committee. Student volunteers. All right, so special thanks to Chris. You know why? Because he was the local arrangements chair, but I think everyone knows that Chris focuses on novelty a lot, right? He comes with a lot of novel ideas. But he did something unthinkable this time. You know what? He was the local arrangements chair. But last night, we tweeted this photo, and Pedro tweeted on this photo, retweeted this photo by calling Chris local super chair. That gave me a great idea. We actually went back this morning and redefined his role to super chair. Thank you. All right, so on that note, we are done with WIST 24 and on to WIST 25 in South Korea. The general chairs for WIST 25 are not here, but they recorded a video for all of us, so we will watch that, and let's see.
Hello, my name is Jian Kim.
And I am Ian Oakley, and we are the general chairs of
Accessibility shortcuts.
It's our great...
Use the tab key to navigate, and press space to talk.
Okay, we'll try that one more time.
Hello, my name is Jian Kim.
And I am Ian Oakley, and we are the general chairs of WIST 2025.
It's our great pleasure to announce that UIST next year will be held in Busan, Korea. Busan is an amazing city for UIST. For those of you who are not familiar, here's a short introduction from the local tourism agency.
In addition to this, Busan is easy to reach, with many direct flights to cities across East and Southeast Asia. Further, regular flights and bullet train connections make it just a short hop from Seoul. Busan is well connected.
Fall is also the best time to visit both Busan and Korea. While no one can guarantee the weather, we expect warm sunny days and cool evenings, ideal for nearby hiking, surfing, even just sitting on the beach.
Food in Busan is also outstanding. Long famous for Korean staples such as seafood, raw fish, and barbecue, it now has many Michelin-listed international restaurants, as well as a range of excellent vegetarian options.
As for the practicalities, we are already looking forward to receiving your work next spring. Submit papers in April and attend the meeting September 28th to October 1st.
Finally, we'd like to acknowledge the superb team already working with us to ensure that UIST 25 is a success. There are already too many to name, but we need more and are still actively recruiting for many roles. If you're interested in volunteering to help run UIST 25, please get in touch.
Our program chairs, Wendy Mackay, Andrea Bianchi, Elena Glassman, and Shandong Zhao are recruiting ACs now and are keen to broaden participation. Please scan the QR code and volunteer.
We look forward to welcoming you to Busan next fall.